With our applications, we now are just going to look at a quadratic in vertex form. So a football player kicks a field goal. The ball passes between the goalposts is at a height of 3.15 meters. Let h represent the height of the football in meters, and let t represent the time in seconds that the ball is in the air. The height of the football can be represented by the equation h equals negative 0.6 times t minus 2.5 all squared plus 3.75. So if we were to draw this, I'm going to make an assumption now that the football is kicked from the ground, goes up, and comes down. If there's something in the way, it's going to hit it, someone catches it, it might not hit the ground, all that sort of thing. Now, remember that vertex form tells us that the vertex is 2.5, 3.75, which means it is height of football in meters. So it's 2.5 meters high at its highest point, 3.575 seconds after it was kicked. Now visually, the uprights, if we think about, could be around here, and the football's kicked, goes through the uprights, keeps going up, and then starts coming down. Or it could be from far away, it's kicked, reaches its height, starts coming down, and then say like the uprights are there. We don't care about the uprights right now because it's just asking us the flight of the football. So determine the height after 1 second. So once again, the time we want to sub in is 1. So after 1 second, 3.75, how high is the football? So we sub it in. Right now, we have all numbers on the right side of the equation. All previous math still exists. So at this point, I can use my order of operations to solve. So bracket. Exponents. Negative 1.5 squared is positive 2.25. Negative 0.6 times 2.25 is negative 1.35. Add them together, and we have a height of 2.4 meters. So there's the height of the football after 1 second. Awesome. How long does it take for the football to reach the ground? Again, we are interested in the x-intercepts, but specifically the positive one. We want to find the x-intercepts and specifically the positive one, the one that's out in front. So if we want to know that, what is the height going to be when the ball hits the ground? Right now, that is when the height is 0. So let's sub in a height of 0 into the equation and solve for time. From here, we can either expand and simplify using binomial distribution or FOIL, then distribute negative 0.6 into those terms, add it, and then factor that, or I can use my order of operations for solving for an unknown. To me, that's shorter right now. That's a scale we have previously. Again, that's locked in there. I need to work the furthest away, subtraction or addition. So take away 3.75. Next thing is any multiplication or division. So I'm going to divide this side by negative 0.6. I'm going to divide that side by negative 0.6. Oh, that's a nice number, 6.25. Now I have t minus 2.5 all squared. I'm going to take the square root of the right side. Math is fair, so whatever I do to one side, I do to the other. Remember that the square root is really going to give me a positive number and a negative number. Square root of 6.25 is 2.5. So I'm going to have plus 2.25, 2.5, or minus 2.5. To isolate my unknown, I'm going to add 2.5, so that equals 0. I'm going to add 2.5 to this side. So my two answers, 2.5 plus 2.5, which is 5, or 2.5 minus 2.5, which is 0. So I was correct in my assumption that the football was kicked from the ground. So the height is 0 when the time is 0. The height is also 0 after 5 seconds. Therefore, it takes 5 seconds for the football to hit the ground, or to come back down, or the football is in flight for 5 seconds, however you want to word it. Awesome. We're going to do one more together to just visualize from a different form. An equipment storage shed has a parabolic cross section. Think of a hay cover, anything like that. So it looks like a parabola. It's a cross section, so if I think about this as like 3D, I can drive in, I can go underneath that way. There it is. But I'm only concerned about looking at it from the side. It's modeled by the relation h equals negative d squared plus 6d, where h is height in meters and d is the horizontal distance, how wide it is from one side across to the other. So, how wide and how tall is the shed? How wide? We want to know the x-intercepts, and then we can see how far apart they are. How tall is it? We're going to need the vertex to find the maximum height. Same idea. So I'm going to just rewrite this equation so I can see it. Now this is standard form, but there's no c value, 0. So the first thing I look again is, can I find a common factor? That's a negative, so I can take out negative 1, and they each have d. So I can take out negative 1d or negative d. That leaves me with d, and 6 divided by negative 1, negative 6. If you think that this is the other factored form, so it's a negative 1 leading, and then d in the bracket, that gives me x-intercepts of 0, and an x-intercept or a distance intercept of 6. So my distance starts at 0 and ends at 6. From that, I can now say that how wide is the shed? 6 meters wide. To find the height, I need to find the midpoint or the axis of symmetry. So my axis of symmetry x, or in this case d, is going to be 0 plus 6. My two x-intercepts, which in this question are my distance intercepts. 6 divided by 2 is 3. So halfway, we have a height of 3. Or so we have a distance of 3. We're going to sub that in to either our factored form or our standard form to find the height. All previous math still exists. That is not negative 3 squared, that's 3 squared, which is 9, times negative. 6 times 3 is 18. Negative 9 plus 18 gives me a height of 9. The last example together is much like the first, or much like the examples in 3.12. We have a y-intercept. Find the maximum height of the volleyball above the court. Determine when it occurs. We have a y-intercept. We're going to factor, find our two x-intercepts, use them to find our axis of symmetry. That's at what time, after the ball is served, the maximum occurs. We'll sub that back into either standard form or the factored form that we would find to find what the height, the max height is. Same idea, give it a try.